Hi everyone, welcome to this video demonstrating the solution to this question. So we've got the pronumeral x here as exponents, and I note here that the base of this term is 4 and the base of this one is 16. So 16 is a power of 4. It's probably a good idea to write this as 4 squared to the power of x. Now over here, I'm going to split this into a product. So 4 to the power of x multiplied by 4 squared, still with plus 1. Now that's one of our index laws, that when we multiply terms with the same base, we add the indices. So I've just split them the other way. Now on this next step, I'm going to swap the position of the 2 and the x. This one here, 4 squared, is 16, multiplied by 4 to the power of x plus 1. I can simplify the way this looks by introducing a dummy variable. I will let a equal 4 to the power of x, and rewriting this, I have a squared equals 16a plus 1. That doesn't look so bad. So let's move all of the terms to the left-hand side. Minus 16a minus 1 equals 0. Now, after a little bit of thought, I don't think we'll waste too much time here. We're not going to find numbers that multiply to give -1 and add to give this. So we'll go straight for the quadratic formula. So we would have negative of -16 plus or minus the square root. Remember, it's b squared minus 4 times a times c, all divided by 2a. Now, the calculator helped me a great deal on this one, and that comes to 8 plus root 65, or 8 minus root 65. Now, I think I might leave it like that. Remember that we had, from back here, we introduced our dummy variable, a equaled 4 to the power of x. So it's time to bring that back. We would say then that 4 to the power of x equals 8 plus root 65, or 4 to the power of x equals 8 minus root 65. Now let's be a little bit cautious here. Root 65, I know that 8 times 8 is 64. So root 65 is a tiny bit more than 8. Well, that's okay, because that's 8 plus another number. That'll be a positive number. That's okay. But over here, we're going to have 8 minus a number slightly bigger than 8. All of this right-hand side here will be negative. So it's not really going to make sense to say what is the exponent on positive 4 that results in a negative number. This one isn't going to give a real solution. So we'll reject that one and we'll just focus on this. Now, this question is perfect for logarithms. If I take log base 4 to both sides, effectively the left-hand side just becomes x, because what is the index on 4 that equals 4 to the x? It's x. And so I just have to write log base 4 of 8 plus root 65. Now when I used my calculator for that one, I got the answer 2.0028. So that's handy. How can I verify that this thing is true? Well, the first thing I'd want to do is clear off all the rest of this stuff that's sitting on my calculator. That's better. And I would want to go back here to my original question. There it is. So let's start typing. We have 16 to the power of, now what did we think our answer was? 2.0028. That's rounded off. So there's the left-hand side of my equation. Now what about the right-hand side? 4 to the power of x plus 2. So I thought the answer was 2.0028 plus 2 in the exponent, and then add 1 to that. Let's hope we get very close to the same answer. We do get very close to the same answer. Now, why is there a small discrepancy here in the fourth decimal place? Well, because we rounded this answer off. This answer of 2.0028, there were more decimals beyond that. But I think that that's very close, and I think that's convincing to say that we have solved the question. Thanks for watching. See you next time.